Hello students, good morning. My name is Dr. Mallikarjun, working in Institute of Aeronautical Engineering in the Department of Information Technology. In the series of video lectures, the course of operating system, today we are going to discuss about the time quantum. Especially time quantum comes in the round robin scheduling. We will see the detail about the time quantum and round robin scheduling. In time quantum is a special parameter in the operating system. Time quantum, also known as a time slice, is the fixed amount of time that a process is allowed to run before being preempted, interrupted, and placed back in the ready queue. So there is a ready queue and there is a running. So the process is in ready state, and the process is in running state. The process can switch from ready state to running state, means that a time quantum is the parameter. A parameter is specifically mentioned. The process can switch from running state to again waiting state. Then again the time quantum can expire. Then it goes to the process from a running state to waiting state. It depends of the process. The time quantums may be vary, depends upon the process. The priority process and the non-priority process also decides by the time quantum. The time quantum is also known as the time slice. It having special parameter in the operating system. So there are two types of scheduling: preemptive scheduling and non-preemptive scheduling. In preemptive scheduling, the time quantum perform a major role in preemptive scheduling. Means the process can be switching from the as per the time quantum. Yes, especially in the round robin scheduling. A round robin scheduling as follows with the time quantum. So round robin scheduling is a CPU scheduling algorithm that allocates CPU time to each process in circular queue, ensuring fair access and preventing starvation. Each process is given a fixed time slice. That fixed time slice, process can expire, then it can switch from that process, from one process to the next process with the time slice. That fixed time slice is called quantum time. It does not complete within the time. It's moved to the back of the queue once the time slice is expires. That comes under preemptive and non-preemptive scheduling. Preemptive scheduling perform the time quantum or time slice, that is TQ. Is typically based on priority or time slicing policies. Mainly a process is switching from running state to a ready state or ready state into waiting state because of the time quantum only. Especially in round robin scheduling, and shortest remaining time for scheduling follows this type of time quantum. Okay, non-preemptive scheduling is not follows the time quantum. If the process can switch to the CPU, it can keeps on executing until completion of their execution time. That means that burst time. That burst time is over, the process can over the next process. There is no time quantum or time slice comes under the non-preemptive scheduling. See, non-preemptive means it cannot be interrupted by the process in the executing in the CPU. In the scheduling, once the resources are allocated to a process, the process holds the CPU till it gets and it reaches the waiting state. See, non-preemptive scheduling comes under the first come, first serve scheduling, completely based on the non-preemptive scheduling. Okay, let me take that how that time quantum is be there in the round robin scheduling. Okay, we see the flow chart of the time quantum is a relation with the burst time in the round robin scheduling. Okay, student. Okay, students, see the flow chart. That first a process is in the ready state. That ready state in the process, then it comes from the next decision symbol. Means that here select a process. Process is going to be selected once the ready state. Here burst time BT. Burst time is less than time quantum. In the decision symbol, burst time is less than the time quantum. That checks in the decision symbol. So in the burst time is less than the time quantum is true. That is true. Then execute till completion. If no burst time is not less than the time quantum, then it go from the execute for next process as per the time quantum. See, process execution is completed, then it's yes, then it going to be termination. It's true, yes, then it going to be termination. So once execution completion, again it goes to be termination. So if process execution completed, here the decision symbol means, here in this decision symbol, process execution completed. If no, again it go to the next, select the next process. So as per the ready state to how the process is mentioned for the time quantum. If time quantum is expires, then process is going to be completed. And if time quantum not expire, it's if you're going to give the next process for the execution. Suppose there are two processes, P1 and P2. So first select a process P1 and that process checks for the burst time. If burst time is less than the time quantum, then the process execution completed, then it's going to be terminated. So P1 is completed. Okay, select the next process P2. So P2 checks for the burst time. Is less than the burst time of P2? No. So process burst time, this process more than the time burst time. So it execute for the time quantum as per that. So process execution is completed, then it's going to be terminated as per the P2. So P2 again is not completed, then again it's going to be ready state in the P2. So this is the way the process are executing as per the time quantum. So time quantum plays a very important role in the round robin scheduling. Okay, let's see the one example how that round robin scheduling execute as per the time quantum. Okay, students, see this problem. So this problem works as per the round robin scheduling. Fixed the time quantum is 3 units of time. 3. So now there are 6 process P1, P2, P3, P4, P5, P6 process. Their arrival times are 5, 4, 3, 1, 2, 6. Their bus times are 5, 6, 7, 9, 2, 3. Now this problem works under the round robin scheduling with the time quantum is 3. Okay students, there is a data structure Q also there in the round robin scheduling Q. So we will draw the Gantt chart. That Gantt chart decides the execution of the process that we will discuss in the previous lectures also. At 0th interval of time, no process is there in the arrived in the execution. So 0 to 1 interval of time. At 1 interval of time, so process P4 enter into the CPU for the execution because 1 interval of time is there P4. 1 interval of time is there P4. So now their execution, their bus time is 9 units of time. Now it executed 3 units of time. Executed 3 units of time. So it left the 6 units of time. It left the 6 units of time. So P4 is enter into the queue. So 1 plus 3 here 4. Here P4 executed up to 4 units of time. 1 plus 3 time quantum is 3 executed 4 units of time. So once P4 is arrived into the CPU, the process which are came into the CPU are so 4 up to 4. So P4 came, then it comes to the P5 is arrived at a second interval of time. P5 is arrived at second interval of time. P3 also arrived at the third arrival time. P3 also came. P2 at fourth interval of time. P2 is also arrived. P2 is also arrived at the fourth interval of time. So P5, P3, P2 is arrived. So and also P4 is executed again again it going to be there in the queue. It executed remaining 6 units of time is left. So here its P4 is completed. Again it moved to the queue. This remaining time for the execution. So now P5 is there in the next in the queue. That P5 starts executing it 2 units of time only. At 6 units of time, P5 is completed. So P5 becomes 0. It is a 2. So it is a 2. It become it becomes 0. Next, P5 is over at 6th unit of time. So what are the processes are arrived in the queue? So P1 also enter into the queue. P6 also enter into the queue. P1, P6 also enter into the queue. So P5 is completely over. It cannot move into the queue because it is completed for their execution completely. So P5 is completed. Then which process can be entered into the next? That is P3. Next process is P3. So P3 is 7 units of time. It executes 3 units. So 9. So here 7 units of time. The left is the left is 7 minus 3. 7 minus 3, 4. 4 units of time is the left for the execution. So now P3 is over and remaining 7 units of time is left. So again P3 is moved into the queue for the execution of the remaining time. So P3 over here. So next P2 is there for the execution. P2 starts for the execution. It executes 3 units of time. So P2 is 9 plus 3, 12. 12 units of time P2 executed. So here 6 is the remaining is 3 is left. That again P2 entered into the queue. That remaining time for the execution. Here P2 is over. Next process is P4. Next P4 enter into the queue and execute for the 3 units of time. P4. So P4 12 plus 3, 15. 15 units of time it executed. So here 6 is there. The 3 units of time executed. Remaining time is left. 3 units of time is left for remaining. remaining 3 units of time is left. So here again P4 enter into the queue because it execute the remaining time. P4 again enter into the queue. So P4 here completed. Next P1 enter into the CPU and execute 3 units of time P1. So 15 plus 3 18. 18 here 3 units completed. Here remaining 2 units is there left. 2 units left. So again P1 enter into the queue for the execution of the remaining time in the queue. So now P1 completed here for the execution. So next P6 starts for the execution. P6. So 18 plus 3 22 21 18 19 20 21. So 21 units of time up to P6 starts execution. So P6 become 0. It becomes 0. It completed totally P6 for the execution. It not again enter into the queue. So P6 is over here. Next process P3 enter into the CPU for the execution. P3. So it execute 3 units of time. So 24. P3 starts executing 24. So P3 become 0 here. No, 1 is there. Starts executing 3 units of time. It become 1 unit of time is left. So again P3 enter into the queue for the remaining time for the execution. So P3 over here. Next P2 for the execution. So 24 plus 3, 27 up to 27. P2 starts executing. P3 completed here up to 27. It becomes 0. So P2 again not enter into the queue. It's over. P2 is over. Next P4 came for the execution. So P4 is 3 units of time. It's 30. At 30 units of time, P4 is also over. So it becomes 0. It can't enter into the queue. So P4 is over. Next P1 is 2 units of time is there up to 32. P1 is over. It becomes 0. 32. P1 becomes 0. P1 is over. Next P3 is there at 1 unit of time. P3. So it executed up to 32 to 33. So it becomes 33 units of time. That 33 units of time. P3 also over. It also become 0. Now all processes are executed as per the round robin scheduling with the time quantum 3 units of time. Okay, now we calculate the completion time and turnaround time and waiting time. Also we will calculate. Okay, next we will calculate the completion time. Next we will calculate the completion time. Okay, next check in the Gantt chart carefully from back to front. Where process P1 is completed, where process P2 is completed, where process P3 completed, P4 completed, P5 completed, P6 completed, from the back to front. So in the back from the Gantt chart, P1 is completed at 32 units of time. So P1 is completed at 32 units of time. That is the completion time of the P1 at 32 units of time. Now where P2 is completed at 27 units of time, P2 is completed. So 27 units of time, P2 is completed. P3 is completed at 33 units of time. 33 units of time, P3 is completed. At 33 units of time, P3 is completed. P4 is completed at 30 units of time. At 30 units of time, P4 is completed at 30 units of time. P5, where P5 is completed at 6 units of time, P5 is completed. So P5 is completed at 6 units of time. P6 is completed at 21 units of time. At back 21 units of time, P6 is completed 21 units of time. Now we calculated completion time. Now we calculate the turnaround time. So completion time minus arrival time, we will get the turnaround time. So this completion time and arrival time, completion time minus arrival time, we will get the turnaround time. like 32 minus 5. 32 minus 5, 27. 32. Completion time is 32 for P1. Arrival time is 5 for P1. Then 32 minus 5, 27 is the turnaround time. Next, completion time is 27 for P2. Then arrival time is 4. Then subtracted from 27 minus 4, that is 23 is the turnaround time for process P2. Then process P3, completion time is 33 units of time. It arrived at 3 units of time. 33 minus 3, 30 is the 30 units of time is the turnaround time for process P3. Similarly, process P4, 30 minus 1, 29 units of time is the turnaround time for P4. Then P5, there is 6 units of time completion time and 2 units of time arrival time. That 6 minus 2 is the 4 units of time is for P5. P6 is completion time 21 minus 6 is the 15 units of time is the turnaround time for P6. Now we calculated the turnaround times for all process. Then we calculated the waiting time. So how to calculate waiting time? Waiting time is a turnaround time minus burst time. Waiting time is turnaround time minus burst time is the waiting time. So P1 turnaround time is 27 units of time and burst time is 5. 27 minus 5, 22 is the waiting time for the process P1. Similarly, P2, 23 is the turnaround time. Burst time is 6. 23 minus 6, 17 is the waiting time for P2. Similarly, P3, 30 is the turnaround time for P3 and arrival time is 3. 30 minus 3, that is 27 is the waiting time for process P3. Now, P4, 29 is the turnaround time and arrival time is 1. 29 minus 1, 28 is the waiting time for process P4. P5, waiting turnaround time is 4, arrival time is 2, 4 minus 2 is 2. 4 minus 2 is 2 is the waiting time for P5. P6, 15 is the turnaround time. 15 is the turnaround time and waiting time and burst time. Turnaround time is 15. Their burst time is 3. 15 minus 3, that is 12. 12 is the waiting time for process P6. Now, so this up to this we calculated so far. But we are not calculated the so far response time. This is a very important response time. We calculated the waiting time, we calculate the turnaround time, we calculate the completion time, burst time, arrival time, everything. But we not calculated arrival time so far. So arrival time is the one which is where the process arrived into the CPU, means here Gantt chart, and subtracted with the arrival time. Then it becomes the response time. See the P1 where it arrived at. P1 is arrived at 15 units of time. So it actually arrived at 5 units of time. So 15 minus 5 is the 10 units of time. The process is the response time of the process P1. Similarly P2 is arrived in the Gantt chart at 9 units of time. The P2 at a arrival time is 4. 9 minus 4 is the 5 is the response time for the P2. Similarly, P3 is arrived in the Gantt chart at 6 units of time and it's arrived actually at 3 units of time. 6 minus 3, 3 units of time is the response time for P3. P4 is arrived at 1 unit of time. It arrived as also 1 unit of time. 1 minus 1 is the 0 units of time for P4. Response time is 0. Similarly, P5 is where is arrived in the Gantt chart. P5 at 4 units of time. P5 is arrived. So 4 units of time. The P5 actual time 2 units of time. So 4 minus 2 is the actual response time for the P5. P6 where it arrived. P6 arrived at the Gantt chart 18. So actually its response time 6. So it is the 18 minus 6. 12 is the response time for the P6. So this is the response time we calculated in the round robin scheduling. So the time quantum is a very important factor I am explaining in this video. If time quantum is increasing, context switchings are decreasing. Context switching means switching from one process to next process as per the preemptive scheduling. So context switchings are decreasing. Once context switchings are decreasing, response time is also increasing. It's a very important factor. Suppose time quantums are decreasing. Let me check. If time quantums are decreasing, context switchings are increasing. It's a very important point. Time quantums are decreasing, context switchings are increasing. Once context switchings are increasing, response time is going to be decreasing. Context switchings are increasing, response time is going to be decreasing. So mainly focus in this video, I am going to discuss about the introduce time quantum, and also I introduce the response time in this video lecture. So response time is the delay before the process receives its fast in the CPU, that is called response time or T. So remaining all same, arrival time IAT, burst time BT, completion time CT, waiting time WT, turnaround time TAT, we all calculated as per the previous lectures and videos we discussed about this problem. But here introduce the response time, the delay before the process receiving its first in the CPU. So in this video, I mainly focused the time quantum. If time quantum is increasing, context switchings are decreasing and response times are increasing. If time quantums are decreasing, context switchings are increasing, response time is decreasing. Okay, students, I explained in this video, introduced the response time, and I focused the time quantum, especially in this video lecture. Okay, students, I gathered this information in the books of Abraham Silberscraft, Peter B. Galvin, George Gangi. The title of the book, Operating System Principles, Wiley System Edition, Publisher, 8th edition, 2010. So, and also I collected the information from the book, William Stallings. Title of the book, Operating Systems, Internal Design and Principles. This publisher, Pearson Education, 6th edition, 2002. We got the knowledge of the time quantum in the round robin scheduling. If time quantum is vary, how it depends on context switching and response time, clearly we learn from this video. Thank you, students. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.